Hi guys, welcome back to the shop. As you can see behind me, I have a 100-year-old bandsaw, and hopefully you guys can join me in getting it running. So what are we working with? This is a 36-inch bandsaw standing at over 8 feet tall, and I place it over 100 years old. Why do I need a bandsaw? Well, this bandsaw is going to be better suited here for the shop. That way I'm not mixing wood and metal together, creating a potential fire hazard when I use the do-all. My plans for the bandsaw are to get this thing operational, and I want to maintain the look and feel of this old style while still bringing it up to the 21st century. The first thing I want to tackle to get the bandsaw running is this drive line. This originally had a big belt drive pulley on here, but it's non-existent anymore. So what I do have is this 14-inch 3-ribbed cast iron pulley. I'm going to mount it to the shaft by the way of this split coupler, but what I did notice is the shaft is too long, so we're going to cut it off and then mill in a groove for a keyway to be able to mount the split coupler onto. And with this pulley and the motor that I have planned for this, we should be turning at around 4,000 surface feet per minute, which is pretty good for general purpose bandsawing. So I think it's going to work out great. Let's tackle a shaft right now. You're probably saying to yourself, Jason, why don't you just take the wheel off the shaft? Well, I would, but I'm a little afraid to break the hub. So if the hub breaks as I try to pull it off, well, and this wheel is basically almost destroyed then, so I'm gonna leave it on the shaft. If it's not broke, I'm not gonna fix it. I'm gonna be milling a standard keyed shaft at 3/8 inch wide, around 220 thousandths deep. If you don't have a milling machine, but need a keyway and a shaft, you can purchase the shaft already with a keyway machined in it anywhere online. There's one more thing I want to address. When we put the pulley and everything on, I want to make a thrust washer that will go in between the bearing housing and the pulley and also the wheel on the other side. This will give the thrust some cushion and a wear surface. So let's tackle that next. So the best choice of plastic is going to be this Delrin AF. And it's basically a fiber-filled plastic that's great for bearings, gears, and surfaces. It's going to see a lot of friction. To save some material, I'm going to split it and make it a little bit thinner, which will be perfect for the bearing. Fresh off the milling machine, I wanted to glue these two parts back together again, but I was unsuccessful. Little did I know, Delrin and super glue don't mix well together. Now the time has come to install the Delrin washer, the key, the taper lock bushing, and the pulley. This is when the fun part comes, where we get to install it all. Well guys, we did it. We got the pulley mounted, we have a thrust washer in here, we have shortened the shaft, and look, it spins. Now I have a target to tackle the next project. And that's going to be getting a motor mount fitted to this machine. I'm going to try to keep the motor fit as tightly as possible to this frame, and I also have to think about how I'm going to build a guard system. This is the beast that's going to be able to take my finger off in a moment's notice if I'm not careful. And it's a 10 horsepower 3-phase motor. It spins at 1730 RPMs, and here's my plan of attack with it. We have to build a motor mount. Now the motor mount, the way I want it to sit is, see this little pocket right here in the frame? I want to nest this motor somewhere in here. That way it keeps this footprint small and out of the way of tripping hazard, and it also really decreases the size of the guard that I need to make and come up with something beautiful that also matches the machine. So that's going to be our task. Before I make any expensive cuts on the water jet, I find it's a good idea to use cheap material like wood or cardboard to do some preliminary prototyping first. And it really helped me out in this instance where I messed up the radius on my first preliminary design, and I was able to go back and adjust it on the second cut. I think I'm ready to do some machining now that we're all done here with the water jet. I got 1, 2, 3, 4, 5, 6, 7 parts. I gotta tap some holes, drill some through holes through these brackets into the ends of these gun looking type parts. And yeah, it should go pretty easy on the milling machine. So let's go do that now. This was supposed to be an easy hole, but I quickly found out the bracket was hitting the head of the milling machine. This hole has been a real pain, so I ended up switching machines to make this easier. I screwed up, and I noticed that these holes were not drilled perfectly horizontal in the bandsaw, which now caused my parts to be askew when I went to assemble them. So the simplest way to fix this is to make an oblong hole. Now it's really difficult with a normal drill bit, but the solution is to use this tool right here, which is called an annular cutter, and it's designed to cut overlapping holes. So I'm going to just come down a good half a hole, pop another hole in there, and we should be good to go again. And we could easily do this with an end mill too, but this is the correct tool for the job. Cool. One oblong hole. Didn't know I was going to be making oblong holes today, but there it is. Before I can do the final assembly, I need to get this motor sled put together. So by tapping some holes with my cool power tapper, and then using the minion squares to align everything up perfectly, I made myself a place to put a nice fillet weld. That way I didn't have to do any V-grooving when I went to go weld these parts together. Now that the sled is welded up square and perfect with the minion squares, I'm able to use it as a fixture to permanently combine the whole system together. So here's a little update on where we're at. We got all the parts cut and finally fitted to this cast, which my fault. I didn't measure these holes. It's casting, it's all not perfect, but we got it working pretty good. We have some in and out with this sled that can slide on these rails. By this sled being able to slide back and forth, it's going to be able to help me tension the belt. And then this plate, by design, is matched to the motor. And all you have to do is just bolt with these two bolts down to the slots on top of the sled, and now you have a in and out. The beauty of this is, for any reason, if this motor were to go bad, I need to change it for some reason, that all I'd have to do is just make a new one of these pieces of base plate that matches the motor base, and then plop any new motor on top of here and off it goes. So the next step we gotta do is tap the holes to be able to go into these slots in the sled, and then mount the motor up. Pretty simple. Time's come to put some belts on the motor and the pulley here. This is a 3-ribbed belt system. I don't really need 3 rib belts. 2 will probably be sufficient, but we're gonna put 3 on here because, well, it'll look funny if we're missing one. So now I need to order a belt and get it coming, but now I need to know what length I need to get. Because this is a custom application, there's a couple of ways we can measure the length of the belt. For one, we can do some math. There's a formula. This isn't the channel to get into math. The second way is to actually go online, and there's actually a pulley belt calculator where you input the diameter of your small pulley, input the diameter of the large pulley, and then give it the center to center distance, and it will spit out a number for you. Or maybe you're in the middle of nowhere and you just need a simple approach on getting a belt made. Here's one way you can do it. You can just take a simple extension cord, something that will sit close to the top rib of your pulleys. You can wrap it around something like this. Make a mark with your pencil, and then stretch it out and measure it with your tape measure, and it'll probably be within a ½ an inch or so. So that's a great way to measure the distance you need for a belt, especially if you don't have a lot of adjustment and you need to nail that exact number. So there's a cool little trick for you. I think the next project we gotta tackle is building a guard for the pulleys and the belt. I've built lots of guards over the years being in maintenance, so this is something that I always dread doing, but I think it's necessary for this project. But I'm gonna change it up a little bit and make it a little more challenging on myself. And I have a couple ideas that I'd like to try. And let me show you how I'm gonna do this. The first thing I'm going to do is make a plate with the water jet that's going to mimic the profile of these two pulleys, and then we'll surround it and wrap it with a curved piece of sheet metal to protect the belts if they were to come off. Now, when those two pieces of metal join, I want to try a different joint system, something that's going to look much like a zipper. Let me show you. So I'm going for some kind of artistic look for this guard. I don't want it to be real plain Jane with some expanded metal and some angle iron. I'm going to try to be creative and push my skills past what I'm comfortable with. So I'm going to try this tab and slot connection, this mechanical connection, one being a slot, one having this zipper-like tooth tab. And when these two pieces intersect with each other, we can peen and bend over the tabs, giving this zipper effect as these two parts are fastened together. I think it'll kind of look neat, but I made some sample pieces to test, so let's go see how they perform at the vise. The tooth shape is so that when we get to the part, the curved metal that we need to form around it, we can get it started into the hole. These two plates are bonded really well together, you can see. So I think I'm going to go with this construction. I think it'll look cool. This edge that sticks out is kind of like a piece of piping on a piece of furniture. This will cover the belts. This will be that part that covers the front of the pulleys. So I think this is a successful test. I think I'm going to run with it. Now that the guard is done, I'm able to use the Fireball magnetic shims to hold and position my guard in place while I design, measure, and build the brackets to hold the guard to the machine. It's always frustrating dealing with an ill-fitted guard. To gain quick access to the belts if ever need be, I designed a quick slip-fit bracket to help installation go fast and smooth. Well, I'm really happy the way this project's turning out so far. The guard's been basically looking like how I want it to, and it's kind of matching the overall theme of the whole bandsaw. I'm also interested to hear from you guys. How should I finish the guard? Should we paint it, rust it, patina it, leave it? But I want it to match the existing look of the bandsaw currently, so please leave those comments down below, and I will catch you guys on the next episode as we continue to work on the bandsaw.